Welcome, and I am pleased to be here. My name is Dr. Bob Bruck, and what I want to do today is talk about the science of climate change. And the way I'm going to do it is by fairly rapidly going through a bunch of slides, back to the old wisdom, the picture is worth 1,000 words, to actually present data to you. This is actually a seminar that I presented at App State, of all places, last month. And I want to abbreviate it today and move through what's going on. I'll begin with a comment that I'm mad as hell. And the reason why I'm mad is we here in the 21st century know full well the power of science and technology, the power of knowledge. Yet, we live in a society today that is replete with denial, greed, with a capital G, I might add, and it really is beginning to get old. I've been doing this for the better part of 35 years, and the compelling evidence to the point right now where it is as close to being as 100% sound as anything we know in science is upon us. We have that data. I am delighted that 2 of my PhD students now are faculty members or staff members at NCAR in Boulder, Colorado. This is the National Center for Atmospheric Research, the #1 climate change laboratory in the world. Over 2,000 PhD scientists that are a lot smarter than I am. I am invited there annually to get a look at what is actually going on. And I come away twice as depressed as when I arrived. The reality is, folks, it's a lot worse than what you are being told. The other reality is that this is not rocket science. This is not rocket science, okay? I think the best thing to do would be to go into the slides, and I'm just gonna go slide when I'm ready to change it because I'm gonna have to move pretty fast through this. It's the PDF file that's on there. Removable disk, that's it. Rock presentation, you got it. There you go. All right, change, yeah, slide. Just push one button. All right, good. We begin with the fact that, you know, I almost get spiritual when I look at things like that. Because, again, back to the science, with all the data, with all the knowledge we have, yesterday you read in the paper that they, quote, discovered 3 new planets, 150 light years out there that may be able to harbor life as we know it. Well, that's nice. But you know something? With all of the knowledge that we have, with all the radio telescopes that are out there, there is not one iota of data to support the fact that there is life on any other place in the universe other than right there. And I remind myself about that all the time, okay? I hope there's life out there, okay? I'm pretty confident there should be, but there's no data to be able to support it. Right around the rim of this blue planet is a 23-mile veil that we call the atmosphere. The other thing that people do not understand, particularly state legislators, is nothing gets in other than light, gamma rays, radioactivity. Nothing gets out other than reflected light. That's it. All the pollution in the air, it stays there forever. A molecule of carbon dioxide is in our atmosphere for 110 years. Take a deep breath. You just left a legacy for your great-grandchildren. Slide. what we call this is the greenhouse effect. Light gets in, and just like in a greenhouse, it heats up the interior, okay, and at night, this glass acts like our atmosphere. You walk over at NC State, and it could be 30 degrees outside. Walk into a greenhouse in the middle of the night, and it's 75 degrees. Why? Because all that heat is being contained by that greenhouse glass we call the atmosphere. Slide. So, very quickly, we all know that 79% of our atmosphere is nitrogen, 20% is oxygen, and the only thing that's left is 1%. That little 1%. Almost half of that 1% is carbon dioxide, and the numbers that you're going to see will be astounding in terms of where that carbon dioxide has historically been and where it's going. Okay, well, how bad can greenhouse gas and greenhouse effect get? We just said that a half of 1% of our atmosphere is carbon dioxide. Let's go to our nearest neighbor, Venus. Venus has an atmosphere that is 470 miles deep, not 20 miles deep, 470 miles. It consists of 97% carbon dioxide. How do we know? We sent probes there. We measured it. We know. Remember, we're talking science. And I get frustrated. Okay? Oh, well, what do you mean science? Like, did you make that up yesterday afternoon? Okay? Excuse me, Senator. I've testified to Congress 13 times. Go to hell. Okay? You're an idiot. You're an idiot. This is science, data. Surface temperature, day or night on the surface of Venus is 870 degrees centigrade. The greenhouse effect. Slide. Well, I don't have to tell you guys that. You know what's going on. Basically, we had a little thing that God tricked us with. During the Cretaceous, 700 million years ago, he put all this dead organic matter thousands of feet down into the ground. Okay, I don't think he expected us to discover it. We did, and thus began the Industrial Revolution. What has been going on since the Industrial Revolution is vertical. This year's global emission of carbon will be higher than last year's, which was higher than the year before. We all talk about Kyoto. We all talk about what we're going to do. Okay? I'm allowed. I love this audience. Bullshit! We're doing nothing. We're doing nothing. It's going the opposite direction. Okay? Talk is cheap. Okay? Future, basically China. You know, I was talking to our friend here before we got started today, and the reality is that the United States is moving very slowly in the right direction, too slowly, regarding alternative energy and recognizing that carbon emissions are not good. The point is, though, is that we have a problem. We've got little countries called the People's Republic of China and India, which will be larger than the People's Republic in 2017. Central Europe, South America. And I remind my audience all the time, okay, when they go, bad boys, oh, they're so bad. You know, China's #1, India's #2 in emitting carbon. Who the hell do you think taught them how to do it? One, and who do they want to be just like? Look in the mirror. Look at this beautiful building we're in right now. What are you, special? You're entitled to this? You're entitled to go to App State or NC State and have an education? You're entitled to drive a car? Well, what about me? Okay, I'm Chinese, I'm Indian, I want to drive a car too. Okay, something to remind ourselves of whenever we want to point fingers at all those bad people out there. So, yeah, good, that's the same one. Okay. So, that is the most famous curve of the 20th century. Anybody who doesn't understand that has been in a cave, okay? I like to brag about NC State. Dr. Charles Humphreys at NC State in 1956 invented the first electrometric carbon dioxide monitor. Electric. Okay, those chemists out there know that in order to measure carbon dioxide, you gotta do these onerous things called titrations. It's a pain in the butt. Now, you suck air into a machine and a number blinks at you. Blink, there's the number. Okay, right in my lab, we got 3 of them. Okay, up on the roof, Jordan Hall. So, in 1958, Humphreys and the EPA put this monitor at 11,300 feet on Mauna Loa volcano in Hawaii. Why in Hawaii? Because it was in the middle of the Pacific Ocean. Why at 11,300 feet? Because there's a lot of airflow. It's constant air moving. They didn't know what the numbers were going to be. Maybe if we put it in New York City, it would be through the roof. We want to know ambient, out in nature, okay? Well, his science is beautiful, his assumption was wrong. Carbon dioxide is identical wherever you go on the planet. Okay? Go to the South Pole Station, Amundsen Scott. It's the same as it is in Raleigh, North Carolina. It's a global pollutant. You breathe out, you burn your car, okay, bingo, it goes all around the earth in a matter of days. What you have emitted. So, you know, my good friend Al Gore did not invent global climate change. Sorry, Al, okay? Basically, by about 1968, the scientists were going, damn, it seems to be going up every year. Every year. It does. Okay, it used to be 1.5% per year, now we're over 2% per year. It never goes down, it goes up. What's going on? You'll see. Slide. Well, I could spend 3 hours talking about this slide. Basically, the Nobel Prize should be awarded for this work because it is so elementary, it is so simple, it is so elegant, which is probably the reason why they won't give it the Nobel Prize, okay? It's too damn easy. Basically, we discovered something on the Vostok ice sheet in Antarctica back in the 1970s. It's called the Vostok because it's in the Russian sector of Antarctica. No one owns Antarctica, they sector it. Politics, okay? The Vostok Glacier is 16,900 feet deep. Got it? 3 miles straight down, ice. So here I am on the Vostok Glacier. I'm 400 miles from the South Pole. Okay, it's springtime. That's usually the time that it snows. I look at, damn, it's snowing. Sitting there. Kind of boring. Okay, no 7-Elevens. Can't get a smoke. You know, not a single 7-Eleven around. Okay, next spring, well, snow again. Next spring, snow again. For hundreds of thousands of years. What happens when snow sits on top of snow, sits on top of snow? Remember good old Isaac Newton? Okay, it's called gravity. Okay, it pushes down under weight and pressure and turns into a glacier. Well, the good Lord left us something, a legacy, just like everybody knows what tree rings look like. Every year you get a ring on a tree. Well, every year a glacier leaves a ring of its, quote, atmosphere, what's depositing in dust, and the water that is in that particular ring. So, I actually have data right now. It's very hard to read this. This is 800,000 BC, right here. The data now, I can tell you, because I've seen it, goes back to approximately 2.1 million years. And what did the glacier data tell us? First of all, it delighted geologists because they knew that due to Milankovitch cycles, we went into glacial periods and out of glacial periods, into glacial periods and out of glacial periods. And indeed, we found out that every 150,000 years, the Earth goes through a cycle, okay? Our latest glacier only melted 10,000 years ago. We have a long way to go before there's a glacier. Here comes Pennsylvania. That's how far down. That's how far down the Laurentian Shield went. Harrisburg, Pennsylvania. You have a terminal moraine right there. The ice was a mile thick, and then it all melted into the world we have today. So, we have two different things. Look at the top one, okay? This is the natural CO2 range. Again, I'm sorry you can't read it. Natural CO2, or ambient CO2 in our environment, okay, is 178 parts per million. Okay, thank you. 178 parts per million. Okay? That's down here. That's where it normally lies. Okay? During the interglacial, the highest it has ever been recorded is right there at 300 parts per million. Where are we today? Right outside that window, it is 402 parts per million. Higher than any other time in history, and going up at 2% per year plus, like clockwork. That data can be extrapolated out for 2.1 million years, and there's no difference. Using stable isotopes of the organic matter that's found inside that core. You'll see what I'm talking about in a second. It's very cool, okay? We can tell the temperature within 1/10 of a degree Celsius, going back 2.1 million years. Ready for this? Again, something that people don't understand. In the past 2.1 million years, the mean global temperature out that window is warmer than it has ever been before. It's warmer, the CO2 is higher, over twice as high as what it should be, okay? All these 350 guys say that you want to have, can I use this, what, the next slide? You can do that, okay? Okay, this is how, okay, move it up, because we got to move it, okay? So, here's our Fred Bostock, okay? This is where the work is being done, slide. This is what we mean. I actually go into the freezer, underground, 400 feet underground in NCAR. There's a freezer about 4 times the size of this room, about 4 times the size. It's kept at minus 40 degrees Celsius. You have to dress up in Mickey Mouse suits to get into this thing, okay? In there are these huge repositories, steel repositories containing cores. The cores are 6.5 inches in diameter, okay? So I, okay, could have a permit from the Prussian Institute of Science. Dr. von Drachenstein would like to have a core from 479,611 BC. And they go into their library, it's a library, and they will find that ring, and they'll slice it off with a laser, and then they will take that cookie, they call it, into the next room. They put the cookie into this giant steel container. You open up the door, you put it on this little ring, close the door and ramp it down. Push the button, and you hear pop, 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 pop. A vacuum is being drawn in the container. Minus 17 torr. Okay, all the air is out. Push button number 2. A little electrical wire heats up the cookie. What happens to it? It melts. All the drippings go into a ceramic cuvette, where that's good, that's important, we're going to study that stuff. But in there are incredible numbers of air bubbles. This is a real picture of what it looks like in an ice core. These are air bubbles. This is water, and you see the tiny little particles, dust, sea salt, trace elements, pollen, insect parts. That's what it looks like under a microscope in that core. Okay? So what's the bottom line? All this air pops, goes into the cuvette, into the cylinder, press the 3rd button, and it goes shoo, and it goes into a GC mass spectrophotometer, and out comes the exact amount of carbon dioxide, oxygen, nitrogen, krypton, argon, neon from 427,911 BC. It's science. Nobody, not even Rush Limbaugh, denies that it's real, but we make it up. Okay, we just fudge that. That's a. What do you guys use on the computer to make art stuff? Okay, whatever. Okay, there it is. Vostok Glacier. That's what these ice cores look like. I'm waiting for my permit to go down. Okay, quickly, in 1 minute. Okay, data. Temperatures are going up. Slide. Data. We know all about the Milankovitch cycles. By the way, right now, today, the Milankovitch cycle, which is a natural, remember that Earth is elliptical, the way it goes around the sun doesn't go around like that. It goes around like this, right? We all took Earth science. What's the bottom line? We are right now at the point where we are getting the least amount of sunshine in the past 109,000 years. Therefore, temperatures should be colder, and they're warmer. You hear that, Senator? It's called science. Go ahead. Okay, what's going on? You don't want to think about it. That's already the data. These are the changes that have taken place. We're already in the Arctic up to about 4 degrees centigrade. Okay, what are the impacts? I would have to take, I teach 4 classes in global climate change. You want to sign up? Actually, if you're over 65, it's free. Come on, come and take my class. Okay? The impacts are ubiquitous. Every single system. Slide. Slide. Don't have enough time to do it. Okay? I have been to the Himalayas. Our poet talking about glaciers. I have been to the Andes. Okay? Glaciers are melting at an unprecedented rate to the extent of miles per decade, not feet, not meters, miles. That is going to have a tremendous effect on global water supplies, particularly in India and South America. Superstorms, we don't know about them. The oceans are warmer. Seal it up. Okay, you got to give me an extra 30 seconds. Okay? Okay. Right down the block. Anybody remember House Senate Bill 819 last year? Okay? We banned global climate change. It is illegal for the sea to rise more than 8 inches during the 21st century in North Carolina. It can do it in South Carolina, it can do it in Georgia, okay? But if it does it in South Carolina, we're going to arrest that son of a bitch, we're going to put cuffs on him and haul him away. Do you know what the minimum sea rise is going to be? Based on the latest predictions from NCAR, and North Carolina is one of the worst due to where its position is on the Atlantic coast. You're looking at a minimum of 39 inches. Okay, anybody have property by the shore? Okay, you need to buy property, oceanfront property in New Bern. That's where the sea is going to be. New Bern, a lot of beautiful seafront. It's like
39 inches and what?
By 2100. That's minimum.
Okay,
minimum. Okay. If Greenland goes, okay, which it could. I have a student there right now measuring what's going on in the Greenland ice sheet that's melting, 16 feet. Okay, waterfront property will be a little east of Kingston. Okay, here's the worst, and it'll be my last slide. This is the worst. Nobody knows about it, and it's the most onerous thing that is happening right now. Horrible. This is real data. Okay, the oceans. Anybody ever hear of the ocean? 72% of the Earth's surface, 34,000 feet deep. Okay, it's a lot of ocean. The pH is changing in the ocean every day due to dissolved carbon dioxide from the atmosphere getting into the water. What it does is it prevents the formation of aragonite, calcium and magnesium. The shells Last year, this is data. Last year, near Antarctica, they were trolling for what are those little tiny shrimp called? Krill. One of the most important organisms in the ocean. Okay? Krill have a shell. Everybody likes shrimp cocktail, right? These are little baby shrimp cocktails. Okay? They have a shell. Guess what? Pick up the krill, put them under the microscope, and the shrimp look like this. Their bodies are hanging outside the shell. Their eyeballs are popping out where they're not supposed to be popping out. Their shells are malformed. They cannot extract enough mineral from the ocean because as the pH goes down, it prevents some of this cation exchange, which allows those minerals to become actually soluble, to take into the body to create that shell. Okay, go. Okay, this is the last one. Last one. Okay? This is a 2-year-old slide. And if it indeed is right, it's over. If it's right, it's over. This is the projection of NCAR, okay, for 2080 to 2099. Basically, the magic number, folks, is approximately 2.5 to 3. That's what these 350 guys are talking about. If we could get it down to 350, we will have a temperature change of 2.5 to 3 degrees. Take a look at the United States. Take a look at the rest of the world. Most of all, take a look at where the ice packs are, okay? Up in the Arctic. If this happens, there will be no Greenland, there will be no Arctic ice shelf. There will be no tundra. There will be no taiga. It will completely dissociate, meaning life on Earth will not be recognizable as to what it is today. This is in the lifetime of your grandchildren. Okay? Finally, the last statement is, folks, is that we were talking about this earlier also. We got to stick in there. Okay? We got to stick in there. Okay, what's going on? They want to repeal the tax credits for renewable energy. Why? Because of Duke. Power. Energy. That's why. Why are we going to ban the seed pricing? Because of developers. Okay? I spent a month trying to think out loud to myself, what the hell is the problem? Okay, are people really that stupid? And the answer is no. They're not. Okay? Something that I don't know how to get around, okay, as fellow communists like Harvard and me, okay? It's called greed. It's as simple as that. I want mine, the hell with you. It's called greed. Until we can get into a global mentality and think about the ramifications of this to every man, woman, child, and organism on this planet, I am not sure how we are going to convince people to make the investment in solar, wind, tidal, all these wonderful things that are there. They're real. I teach an entire course on renewable energy. It's real. Today. It's not something in the future. It's now. You can do it today. Stick with it, guys. God bless you. Thank you.